All right. So today, we are going to be talking about using APIs for automating some network element deployments. My name is Ryan Shoemaker. I come from Chicago, Illinois in the States, and I thank you for bringing me here because I got out of there right before the snowstorms hit, where my kids have been staying home because school's been closed for 3 days from the snow and the cold weather. It's much nicer here, but my wife's not too happy with me, but that's okay. It's much nicer here. I'm a technical solutions architect. So basically what that means is I'm on the sales side of Cisco, on the technical sales, like a systems engineer, but I focus on LAN and WAN technologies. I've been with Cisco for about 19 years, and I grew up with command line interface, programming routers, programming switches. Over time, one of my passions, the things I've started to really spend a lot of time on is the programming aspect. So fortunately, I get to spend some time here in DevNet, teach a couple sessions on things that I've picked up over the past few years. And one of those happens to be around using some of these APIs we have for automating network element deployments. Right. I bring that up just to point out for those of you with a networking background, show of hands, how many are networking background people? A lot of you. How many are programming background people? A few, but not nearly as many. So I'm a networking background person, so you may know a lot more than I do. You may be just learning programming, but it's a transition that I think as network engineers we really have to undertake and learn a lot more about, because that's how we're going to get things done in a better fashion. It really brings up what we'll talk about initially with the introduction, but before I do that, quick agenda. Here are the topics I'm planning on covering today. Sorry, I'm going to speak up a little bit. We're going to talk about using our toolkit of zero-touch provisioning on iOS XE, on iOS XR, and on NXOS. There we call it POAP or POAP, right? Power on auto provisioning. We're then going to spend a little bit of time talking about plug and play, a toolkit we have within iOS XE devices. We're going to talk about leveraging some of that plug and play using APIs with Cisco DNA Center. So we'll cover that a little bit. And then I'm going to touch on a bit on using other toolkits like REST to do programming for network elements as well. And then we'll wrap up. We'll get all that done in about 45 minutes. So hopefully it'll be a good journey here. I think there we go. Sorry, I must have moved too far away. So obviously the problem that we're looking to address with things to do network element deployment using APIs is we're stuck with this problem we have and had for a long time, which is that when you provision network elements, network devices, we have traditionally done things on command line interface, and we've done them very manually, one at a time. You get a box, you either send a resource on site or you bring it into your house, your office, you put the right image on, you put the right configuration on, and then you either connect it or you ship it to its destination. You do these one at a time. Typically, it's a very manual process, and of course, that means it's very error-prone, right? It's hard to repeat. It's hard to scale. How do you scale that process when you're looking to do thousands of devices instead of I just have one to replace or one to turn on, right? So there's the problem statement we need to start tackling. I might have to stand over here. Okay, I think I'm getting interference. So let's start by talking about what an API is, right? An application programming interface. Probably everyone here, you know an API, show of hands, know an API, use an API, right? Okay, right? Just a simple description, how an application talks to another application versus using that command line, hit the keys and all that kind of stuff for a human user to a device. So as we look at how API machines talk to machines and working on improving those processes, one of the first times we're going to talk about today is using some APIs we've embedded within iOS XE around a framework we call zero-touch provisioning. Show of hands, how many here are familiar with zero-touch provisioning? And we've met before, I think, haven't we? I'm just trying. Sorry.
I had an interesting podcast recently where a colleague of yours gave an overview of the whole technology.
Oh, okay, all right, very good. Well, we'll talk a little bit about that and other things here, but for those of you who don't know, zero-touch provisioning we list it here. It's this open bootstrap concept for getting boxes onboarded, things that cannot find basically a device's requisite startup something, right? Comes online, must have something. If that thing is missing, we can actually go into this bootstrap to automate an onboarding process. We call it zero-touch provisioning. As I mentioned here, it's used for heterogeneous device types, right? I said in the introduction, in the outline, we're going to talk about iOS XE, so think Catalyst switches, think routers, ISR 4Ks, ISR 1Ks, ASRs, those kinds of things. We're talking about XR devices, so think about the XR router series, ASR 9000s for instance, and we're talking about Nexus devices, right? NXOS devices, using the same framework across those three device types. Basically things that really don't have much of a GUI interface to use other API type frameworks you might find more common in those, and we'll cover that at the end. In addition to having this bootstrap process that fires up, we've embedded some additional APIs with the typical programming language types you might see. We'll get into details on those, but I've mentioned it's going to be things like Python or Bash for a shell script. We've embedded additional API structures in there to allow this onboarding process to take place more easily. And I did just mention here, running across 3 major families that we have within our device types. Within iOS XE specifically, an iOS XE device will actually enter the zero-touch provisioning mode when installation starts and it cannot find a startup configuration. If it's missing that startup configuration, we have a process in place where we can actually enable something called a guest shell service within the XE device. I'll cover that in more details what that means, but it's a highlight here. But it really is an environment to execute some Python, to be able to turn on or start leveraging Python and do some Python scripting to then fire on how you might want to actually really program a device correctly. Bullet points here. We leverage DHCP, as you might expect. How does a device onboard if it doesn't know anything? I DHCP for an address, right? When I get my information from my DHCP server, it might point me to either a TFTP server or an HTTP server, and in that place, point me to a particular script, a Python script, that the device would then have to go and acquire, download. I have a couple of versions of iOS XE that we started supporting this service in, right? As well as families of products. So ISR 4000s, CSRs are not actually in here, the virtual router, the CSRs, ASR 1Ks. And then we have the Cat 3000 series family, and the Cat, I put 93s and 9500s here, just because the 9400s gained this support in 16.6.2. But it's here for all the families, has been for a bit of time. We're still waiting on the ISR 1Ks, they're roadmapped. We hope that will happen in the springtime, so I'm still looking for that to happen. Now, I mentioned that when I go out and figure out I don't have a startup config, I could fire up this guest shell service, right? How many here are familiar with guest shell? Okay, we've got a couple. There, by the way, I'm going to touch on these things. If you want to learn more about some of these, obviously there are many sessions throughout the week you can attend here at DevNet. But if you look at what we have in I've drawn a block of a kind of an iOS XE device here. We've got our network OS. Separate from our network OS, we have our open application container space. That open application container space is something that we've created in XE to allow you to, anyone to basically put container type applications and run them on the unused CPUs within our system. But we've embedded in XE guest shell that runs in this open application container space. You can see it's isolated, so both resource and fault isolation is what we've done that, so to protect the network OS from things you might be doing up in here. But in here you see we also have an API structure, a framework that goes between the two. Right? So there are APIs we've built that allow communication between these, and I'll cover those as we talk today. So let's go over the process. We have an XE device, fires up. Again, I mentioned, doesn't have a startup config. Right? No startup config. This device is going to DHCP on connected ports. right? You connect a port to it, it's going to try to DHCP on that particular connected port. I can get a response from my server, and in that response, I might offer up a TFTP server with an option 150. Right, if you're familiar with the old voice days, right, we did option 150 for phones registering to point it to its call manager. I shouldn't say old days, we still do that. But in addition to that option 150, I can point it to a particular file using option 67 that I want it to grab. This file needs to be a Python script for XE. I then make a TFTP request to that server to obtain that file. If you note here, I've given it a name, iosxe1.py. I locate that file, send it down to the device. The device, upon attaining a file, automatically executes its guest shell space and enables its Python capabilities in that open application container space. You okay so far? So, when I send that file back, and I want to have that device execute that Python script, two basic ways I can do things with this return script. I can A, implement using that API structure I showed you, which integrates, I don't know if that was me, integrates some command line interface. And by doing that, I can actually then instantiate my config. I could even just copy a complete configuration file or a version of software, as a matter of fact, at the same time, and run it in the iOS XE device's running configuration. If it is option B, perhaps what I might do is have this Python script that I sent down execute a series of calls and include it in there. Hey, go grab this config and install that within the device. Now, I mentioned option A was leveraging some APIs that we have built within our guest shell Python container. What do? Well, we have particular calls that we allow between the Python that's running in that guest shell and the network OS, the command line interface. I have a module that we have created. We call it the CLI library. If you're familiar with Python, Python works by importing libraries. That's how it learns to do things, to allow commands to be executed. We've built this CLI library, so you use an import CLI in your Python script. And by doing that, I've enabled this set of commands within Python to make calls against the CLI. You can see what we have here. I've got a CLI command. It's going to take an iOS command as that argument there, and it's going to run it through the iOS parser. If we put a P on the end, we'll print the result. I've got an execute version of that. I want to make an execute level command, right? I don't want to go to exec mode and other things, just execute it. Or I have a configure option, which you should use if you're going to be doing configuration level commands within the device. All cases, I can either return the result or print the result if I use a P. Worth pointing out when you use this module within your Python coding, if you want to do a set of commands, they operate independently. So you don't here, for example, have, hey, I want to execute this command conft and then this command hostname switch1. That will fail. They're operated independently. If you wanted to do something like that, you would just have a series of commands separated by a semicolon. This probably isn't the best way to configure that, because since you're making configuration change, I might recommend you use the configure command, right? That one we build as an array, but I've got a series of commands in quotations separated by commas. Very simple thing we're doing here, right? We're just going and creating an interface loopback and assigning an IP address to it. So let me show you an example of a script you might actually deploy as a full Python download when you get that option 150 and option 67. So first off, it's Python. We have to import libraries. In this case, the only one we're importing is the CLI library. For this script, I've got a series of CLI commands I'm using. They're really show-level commands. You could actually sit in front of the console when the device goes and downloads and starts its zero-touch provisioning process, you'd see these things come through on your terminal monitor, right? So I'm executing a set of commands. You can see it's just a simple execute P. I want to print it. And the commands, show platform, show version, show IP interface brief, typical CLI commands. This one is actually showing how you might use some configure commands here. Give the device a name, enable a loopback address, turn on routing, right? The set of simple commands that come back to basically get the device onboarded without any manual user intervention. I said that option B was I could also just push a full config file. First off, kind of missed the highlight here, but again, I'm importing the CLI library, also the sys library. And here I'm just naming a file. Whoops, sorry guys. Didn't build that quite correctly here. And in here, I'm actually going to just do a copy as a CLI command and copy the files that I've identified here into the running configuration. All right. So these files would be present on that TFTP server as Python files. Now, how would you actually configure something like your DHCP server to be able to offer this capability up? Here's an example of using a DHCP server configuration where I basically give it the subnet and the range, but I need to identify this device coming in. Because if you remember from the earlier example, I was pushing that Python device 1 file. Well, that's unique to the device coming in, right? So I must identify that device to know what file to push to it. Within XE, I can give the fixed IP address, but I can actually identify the hardware here by the MAC address of VLAN 1. So when this device comes in for a DHCP request, it'll give its MAC address of VLAN 1 as kind of its identifier, and DHCP can then take that information to uniquely identify it and return not only the TFTP server, but the unique Python file that should be sent to that particular device. You might have this TFTP server I'm just showing. It's got a collection of different Python files, right? I identify that one to know which one to push. Something else as a little more complex implementation. Now, identifying things based on like their MAC addresses, I can uniquely identify them obviously, but it might be a little more challenging because how do you identify that MAC address prior to shipping the box out, right? Might be more useful to have something like a serial number, right? Something that you know ahead of time what that device is going to be by looking at the out of the box or off your order number. We can actually allow that iOS XE device to provide its own serial number because we can see a query as part of the Python return. We can tell the device to identify its own serial number through a set of that CLI commands using that API. And then that server could provide a specific query using its own serial number as the source to the TFTP server or to a REST server, let's say, in order to say, hey, I'm this particular serial number, I need you to provide me some values back. There's an example of how we do this here at this link, which, of course, if you downloaded the slides, you'll be able to get this link to look at it later. But let me just show you graphically what this would look like. Again, step one, identified I have no startup config. I DHCP. I get my return results back, pointing me to a particular, let's say, Python script here. I TFTP, get that Python script. A little hard to read maybe here, especially for those of you in the back. But this is a component taken from that example on the link I just showed you, a part of the Python, which is a definition called get serials. And really all it's doing here, if you could read this command, is I'm executing that API structure to use a CLI command called show inventory and piping it to a format. Out of the box, I would pipe it to XML. Within that list of inventory piped to XML is contained the serial number of the device. So from here, I can use typical structuring query. Because XML is structured, I can go find that particular information. I'm telling it to dig into the element of switch, and in there find the node called SN, which is the serial number. Once you find that node, map it to the serials, and then return that value as part of this definition. That allows this device within its Python to say, okay, this is now I know my serial number. I can then make a query. Now that I know my serial number is foo, I can make a query using maybe a REST call, like a typical get devices, my SN is foo. Ask this guy to basically take from a data. You could actually have a CSV file. Structure isn't important. That CSV file may be the serial number as the source. Uniquely identify 3 or 4 elements or variables that could change. Perhaps it's the VLANs, perhaps it's the host name, perhaps it's the routing protocol you're putting in place, but set up the structure in such a way that that CSV file has those contained. And when I go and make this request, I can script that on the back end to say, well, return those variables, those unique device values back to this Python script. The Python script may already have most of the configuration in place that was downloaded here, has now the variables that are unique to itself, merges those up, and executes the configuration script to deploy itself using unique elements. And all you had to provide was a CSV file identifying the unique elements married up to a serial number. Okay? All right, so we're going to change tracks a bit and talk about ZTP with an iOS XR. What's nice, as I mentioned at the very front end, we kept this framework for heterogeneous environments. So a lot of the things I just talked about are going to be very similar across the different iOS OS types. Excuse me. So iOS XR will fire up. The difference is, rather than looking for a startup config, it looks for a username. If it does not have a username present, it initiates the ZTP process. This case, I go to DHCP. Instead of TFTP here, I'm going to ask it can return an HTTP server. Same concept. But what you'll note differently here is I don't return a Python script, right? Because XR today doesn't have a Python interpreter embedded in the operating system, but rather we're going to leverage shell or a text file to return that particular information to the XR device. I then go to my HTTP server, grab the information, and get that returned. Now I bring this up, the configuration is going to look very similar to what I just showed you for the XE. Again, it's that framework. What is different is if I'm going to identify it by a MAC address, it's the management MAC address, right? This comes to the management port, right? It's not VLAN 1 or anything like that. That's how XR will operate, because it's not a VLAN device. Additionally, XR today has an option called a DHCP client identifier. We can actually get the serial number. It'll send up its serial number as part of a DHCP client identifier. So we can actually use the serial number with an XR to uniquely identify the device in order to return things. Now what might get returned? I said it had to be a text or a bash file. It's really going to be a text file either way. Here are some requirements. It's a text file that's less than 100 meg in size. XR is going to analyze the file that got returned. It must either start with a bang bang iOS XR. If it does that, it interprets this as a config file, passes it to the CLI interpreter, and then commits it. If it starts with a shebang bin bash, shebang bin sh, it's a script, so start its execution. If it's anything other than these, it's going to erase the file and terminate the ZTP process. Similar to what we did with the Python API components within XE, we've put in a series of shell helper utilities within XR. ZTP_helper.sh. They're embedded in the XR operating system. To get those, this isn't Python. We're not going to import them. Rather, we're going to source it. ZTP_helper.sh. And what you can do in those are going to look pretty similar to what we just showed with that CLI integration, basically using the Python API. We have an XR CMD, runs an exec command within iOS XR. We have an apply and an apply with reason. Those two commands will actually merge a file with the running config. As an example, here's a simple file. The file is really just hostname Saturn, end of file. If If I XOR apply with reason, the reason is this is an important change. This is the file you're going to take, hostname Saturn, and you're going to merge it with your running config. We also have an XOR apply string and a string with reason. Right? In case you didn't have a file, you just wanted to have a series of commands. You can see here the XOR apply string, hostname router, new line, interface VLAN 1, so on and so forth. So in case you didn't want to do, just put it out as a string versus a file, you can have that option as well. All right, we'll take a look at a sample here. Right. First off, it's bin bash, right? It's a shell script we're going to execute. I need to source that on-box utility set, ZTP helper.sh. This is really the main part of the script entry point. I'm going to look for a config file, remove it, else I'm going to build one. But then I'm going to activate all IF, which is the function up here. And in that function, I'm actually going to execute a few of my utility commands. Well, I basically made it a variable, right? My variable interfaces is that XR command show interfaces brief. I call that within this loop to identify all of the interfaces that exist within the system and apply that to a config file, a file called config file, and then I end up applying that to the reason to the actual running config. Now, we also have, certainly because we're doing scripting, there's certainly more complex implementations you could leverage. Similar to what we talked about at XE, you could have a CSV file on the back end. So use that same HTTP structure to identify, using that hostname variable to identify what it is and return some information, leverage REST as well to make another post call just like we showed before, and download the specific parameters for installation. Example of that can be found here. If you want to look at how to do that in more detail. We talk a bit about how Nexus operates, POAP, which is similarly based off the same ZTP framework, but hey, we wouldn't want to call it the same name. That's too complicated. But when an NXOS device turns on, looks for the startup config, just like XE did. If it's not there, I go out to DHCP. I can do either TFTP or FTP, actually. Give it an IP address, the option 150, option 67, right? It's going to look very similar to what we did with XE. And on that server, config, a kickstart image, a system image, I put all those in there. Now, building this as an example, this is going to look very similar to what we showed with iOS XR. It also can leverage the DHCP client identifier in the more recent versions of NXOS. So I can use a serial number to identify it. I could also use that the MAC address to be the identifier if I wanted. But we've built the API for the Python module in NXOS as well. And you're going to see import library or import CLI, right? Similar commands to what we saw before. One of the big difference, there's actually a D version which actually returns JSON output for the CLI command. I just put this one in here because even though everything looks the same, there is one difference in how you apply that CLI command, the CLI API within NXOS, that library. Semicolon separation, and you must have a blank character on either end of the command. Okay, so there's a caveat just to be aware of. And we have examples of all this, things you can download right on Cisco.com. They're existing, they live right within the Nexus library of downloaded software. So here's an example of the Python script right here you can grab and download if you want to test it out for your deployments. I put some links in, some additional references, but they're based off the same framework. So if you learn how to do it in one, it's going to translate to others as well. There are obviously, as I tried to point out here, a few nuances. So you just need to be aware of those as you're looking to do it across multiple device types. All right. So I'm going to change gears a bit, and we're going to talk about REST. All right, so REST, if you're familiar, or if you haven't heard of REST, most people, it might be pretty common at this point, is basically an API type that communicates over HTTP. So typically you're going to find it with devices that have a GUI, right? Because since they already have a web page, they're already using HTTP, it's much simpler to implement REST as an API structure when most of the work is already done than enabling something new. I put in here, and it also returns data, different formats per request, returning data in XML or JSON, so it means I can structure it and search it and do things with it. We utilize it within Cisco DNA Center, within our vManage solution, our SD-WAN solution, Firesite Threat Defense or Firesite Management Server, just a few examples here. But almost all of our network devices that have web GUIs, you're going to find we have some form of REST enabled on them for automating things. Now this particular discussion, of course, is about getting devices on board with no configuration, so I'll spend time talking about how we do that. But REST itself, if you weren't aware of how it worked, it's basically this client request with what we call a method. Typical HTTP methods, it's a get, put, post, delete, right? I need to get information, I need to send a change to something, or I need to delete data. Calling the API service to do something, can do that thing, and then send a response. This is a typical REST request. I have a server identify, a resource, right? This resource then is typically the API itself, and then there may be some additional parameters that have to be sent with it. Right? Now how it fits into what we're talking about today is I'm going to talk about using something we have called Plug and Play, which exists within iOS XE. Plug and Play is an agent that we put into XE to basically help onboarding processes. It's typically been aligned to what we do with our Cisco DNA Center. We're looking at this example of, again, I don't have a startup config within this device. So I fire up a DHCP request, actually. I get an IP address, but instead of returning an option 150.67 that we just saw before, I return, in this case, an option 43. Option 43 has some syntax here that basically points it saying, this is a plug and play request, right? I'm telling you to enable your plug and play service. That's what this indicates. IPv4, HTTP. Here is your IP address for your plug and play server. Communicate over port 80. So then I can reach out as a plug and play initiation to that particular device, in this case the Cisco DNA Center, to start my onboarding process. Now you can do this, of course, through the Cisco DNA Center GUI, but maybe you're programming this and automating it on a script and don't necessarily want to do all the clicks, drags, and drops. So we've opened up a series, or we have API REST calls that allow you to do this through programming in order to get your plug and play process done through a more automated scripting methods. The call out here, I'm showing you an example of using an API call. You can see up here, I have a method, right? I have an IP address. Sorry, I have an API, right? I need to point out that to make API calls work against Cisco DNA Center, or REST calls actually to work against anything, you need to authenticate. Now, some devices you can just send a username and password, and that's okay to do authentication. We're seeing a movement more towards a token method because, of course, that's more secure. So Cisco DNA Center requires a token. In this case, this would be the API to request the token from Cisco DNA Center for a series of communications. I get that information returned, and then I can use that token excuse me, on ongoing API calls for the session. My method for authentication, instead of a username password, is XAuth token, and I put that token in here. Here I'm just showing an example of I'm getting information from Cisco DNA Center about what devices are in its inventory. Right? That's what I see. For the world of plug and play, I'm showing you an example here. We have to use that token. I'm showing right here where we would tell it I'm going to structure my data for JSON. Remember we talked about it could be JSON or XML. I'm structured by JSON, but on that API call, I need to create a plug and play project. So I put some information in JSON format here, for instance, saying, well, here's the name of the project, here's a description, here's an ID. When that information is sent off to Cisco DNA Center, then you get a 200. This is a good call. I understood it. I return. This is the information you might need. I understood your name and your description. I've also identified your plug and play project with a unique identifier. I'll need that information later. You'd have to upload an image. We can do that through APIs as well. Right? Here's an example of how you do that. A post request, right, with that particular API. I'm giving an FTP server and the image to download, or I'm sorry, upload. All right, we get some information returned on that. I also would have to upload a configuration. Right, this one I have just a simple text file, cat9k config. 200, that was okay. Now once those pieces of information are uploaded, then I can go and create an API, or use the APIs to basically say, let's go provision the device when it shows up. So I have a post to the plug and play project API, and I'm identifying that plug and play project that got created in the first step. In there, I have to give it some information, such as the image and the config I want applied, as well as the serial number. So when this device comes and phones home to you, you're going to apply this image and this config to it. I put all that in place, send it, and I get a 202 accepted, and it tells me I've successfully created not only the plug and play project, which we did a couple steps ago, but I understood for this device, that's what I'm going to apply, and I'll sit here and wait for that device to phone home. So again, you can do these things through the GUI itself, but as we look towards automating with scripts, you can use Python to leverage these same types of commands in order to build it in a more automated fashion. And that's a very high level overview, and I know we have a lot more sessions here about using the APIs within Cisco DNA Center. There's a reference from the DevNet connection here, so that link will give you more information on using them. I specifically was really just going to focus on plug and play as part of our discussion today on using APIs for onboarding devices. Now we've also built APIs, as I mentioned, with other device types themselves on the REST world. So as an example, Viptela will also leverage APIs, right? In the Viptela, it's going to be a username password authentication, right? And that's how you would get the authentication done in order to leverage those calls. One of the things we have in the Viptela space is there's actually an on-box REST API, kind of explorer page, if you will. It's here, the IP address of your vmanage/API docs. And in there, you'd get a page that looks like this, right? It's built off of Swagger 1.2 release. The nice thing about Swagger is not only do I get identification of the APIs that are in here, but as you click to expand it, one of the things you get right in here is you get the ability to test out the API, right? So I can put in data in here if I need to. It'll tell me if you need to include extra data, like we saw in that plug and play project before, how to structure that data. And then I click the test button, and immediately I understand whether or not I made a good call or a bad call in order to make the changes. So it's easy for testing purposes. So you can test them right on vManage without using another tool to do so. Fire Site Management Center, as another example, also has REST APIs. Just point out that the authentication for Fire Site Management Center is also token-based. One key difference is, as we saw in the example for DNA Center, that token got returned in the body of the data that came back. In Fire Site Management Center, it actually gets returned in the header information. So you got to extract it somewhere else for your programming. But it's there, and you use that token then for ongoing API calls. Now, on Box, it also has an ability to take a look and explore the APIs that are available. IP address /API/API-Explorer. And here's what you would see. So I get some examples, and a deployment example showing here that I can make a post type request to this API that says, creates a request for deploying configuration changes, for instance. And so I get information in there, along with the elements of things like, do I need to have a body, which is data sent to the device in order to execute that full API call? Yes, I do. You know, JSON's data structure is what a Fire Site Management Center would like. Okay. All right, well, as we're wrapping up here today, we've talked about a lot of different technologies for doing things. Primarily, though, if you boil it down, we talked about zero-touch provisioning for our devices that do not have a GUI. That framework we're trying to make very consistent across iOS XE, iOS XR, and XOS. You learn how to do it with one method, right? It's easy to translate into other methods for different device types. Python, shell scripting, these are common tools that you're going to use for deploying things, but we're trying to make it easier to get those things up and running without requiring any user intervention. Turning on a Python shell when you first fire up an XE device and it doesn't have a config makes it simpler to get things onboarded and processed. So that's the zero-touch provisioning framework. The second thing we really talked about was REST. For those devices that do have GUIs, you're typically going to find REST. And I can still do onboarding of devices through REST as well, typically being able to find something like a DHCP service to do it, or pointing towards something like plug and play for those devices that support that. We utilize APIs to give improved performance, right? We have that Python API set we talked about for iOS XE and for NXOS, so I can do things with my Python script into the CLI, and I've got the bash shell helper utilities, ZTP utilities for XR for those open API concepts. I'm sorry, yeah, those API concepts. And then we use those tools, Python bash, for more complex configurations. All right? So that's what I had to share with you guys today. I thank you for attending Cisco Live, and I think if you haven't been to enough sessions already, we've got the WebEx team space. Please join to continue the conversation. This particular session is DevNet 2323. My name again is Ryan Shoemaker, and I'll just point out this is the first time we've had this session at Cisco Live Europe. So as you've heard today, please ask you if you take the time to complete the surveys, because we work pretty hard to get these things together for you guys. We want to make sure they're useful. So if there are things that are good or there are things that are bad, we want to know so that we make the right modifications so they become even more useful for your time and the expense you put into coming here. All right, so thank you very much.